Hi there, good morning. Welcome to another session from the QCon Plus conference. If you're interested in how to transform batch-oriented systems into streaming systems so you can start harnessing the power of whatever's happening right now, and by doing so, start discovering new business opportunities that your company can leverage, and you also happen to be working in the financial services industry, you are in the right session. You came to the right place. So in this session, we're going to discuss exactly this, the journey that you and your teams can undergo to start harnessing the power of streaming-based systems. And if you happen to be working with batch-oriented systems, what is going to be the journey that you and your team needs to undergo before you actually start collecting the benefits of this architecture style. So without further ado, let's get started. The most common reason why people these days are looking forward to implement streaming-based systems comes from the realization that the world has changed. If you think about it, most companies these days are becoming software, which means that all their internal and external business processes and policies and systems need somehow to communicate to each other in order to provide a better or superior customer experience that could differentiate their businesses to other companies. That requires them to rethink in how they are treating data. Traditionally, most companies have been using data in two main phases. The first phase is the phase known as the capture and storage of data, where they start collecting huge amounts of data and then they're just stuck into some sort of a data store. And the second phase is where they start actually analyzing that data to see if there is something relevant to be done with them, and therefore try to create a superior business opportunity or identify a business threat. The problem with this approach is that by the time the data is analyzed, somehow the data might have lost its value because it's past tense. It's already happened, right? So the only way to businesses to actually leverage the power of what's happening right now is to transform their processes and systems in a more reactive way, right? Meaning that they need to start bringing the processing of the data as close as possible to when the data is actually captured and when the data is stored. All the three phases, capture, storage, and processing, almost have to occur kind of concurrently, so they can start treating the data as something that is going to fuel a better way to provide superior experiences or different business opportunities. There is this very interesting report that has been created by Forrester called Perishable Insights. And this report talks exactly about this, the analysis of the value of the data and how that data perishes over time. So traditionally, we have been designing and thinking systems and processes that are going to make usage of that data in a period of days, months, and perhaps even years. Whereas systems that are more time sensitive, those systems and processes or situations that requires the company to react as soon as the data happens, they need to be designed in such a way that they respond to those situations in a matter of seconds, minutes, or sometimes even fractions of seconds. So this is the rise of what we call the rise of streaming-based systems. My name is Ricardo Ferreira, and I'm a developer advocate with Elastic, where I'm part of the developer relations team, which is also known as the community team. Before working for Elastic, I used to work for other software vendors such as Confluent, Oracle, and Red Hat. And I also spent a significant part of my career working for consulting firms, implementing and designing systems that are somehow related to distributed systems in general, or are based on big data and streaming data technologies, as well as databases in general. If you ever feel the need to discuss any of the topics with me later, I'm providing here my emails, both from Elastic and my personal email. And at the bottom of the slides, you will find my Twitter handle, where if you use Twitter, feel free to follow me there and get in touch so we can start a discussion about any of these topics. The best way for us to understand the benefits of streaming-based systems is to analyze how companies build systems today. And most of them, you're going to see this very own concept of silos that is rooted in how we design systems for the last decades. In the siloed-based architecture, each system will be treated as their own project, and most importantly, each system will possess their own data store. Regardless of what data store is this, the problem is that data stores won't talk to each other, and data won't be made available right away. So that means that an inherent batch will take place in order for data from one system to replicate to another. And that is directly what causes the problem of perishable data, right? Because we are now creating some delay in when the data will become available for analysis and or transforming into something useful. Also, today's techniques of transferring data from one system to another or replicating this data is very hard, right? Most people spend a precious time like creating jobs and scripts and programs and using ETL tools or any other replication tool that is available in the market to do exactly this, to read data from one place and copy to another. And by the time they actually have to keep managing these systems, that creates a more fragile architecture that don't scale very well. So this is another problem for that is provenient from the siloed-based architecture. By contrast, if we think about how we could leveraging the power of what's happening right now, is to shift to another way to actually handle the data. Instead of actually storing to analyze later, we have to start actually analyzing data as they happen or come through by using a mechanism that we're going to discuss later. But the secret of adopting a streaming data platform is effectively making the data and the analysis to happen concurrently. So a better way to understand this is, in the past, in the traditional way for designing systems, we would store the data and the queries would be applied to that data to perform the analysis. Now, in the streaming data world, we actually query the analysis. And the data is what keeps flowing in and coming in all the time. And the data is applied to those persistent queries that are going to leverage the power of whatever is passing through the data structure that will contain these streams of data. A good example to how streaming data architecture will transform this into business opportunity is by looking into the possibility of correlate different data sets or different streams of data and create a situation where a company could actually benefit from discovering a business opportunity or perhaps a threat that, if they start treating their systems as silos as they were doing so far, they wouldn't be able to analyze this and evaluate this as soon as possible. So streaming data architectures are very good to provide the tools for companies to start reacting to opportunities as they present themselves. I've mentioned before that there is a data structure that you need to leverage so you can implement streaming data architectures. And this data structure is called a commit log. A commit log is something that looks like a lot with a queue, but different from a queue that is transient in nature. A commit log is supposed to be persistent, meaning that you can store data in the commit log and you can analyze it multiple times. And also you can go back in time in the commit log and read and process data that has been stored as seconds, minutes, hours, days, or months ago. A commit log is not necessarily something new. It exists for a very long time, but developers of database technologies choose to not expose the commit log directly for the users, and instead they decided to encapsulate into something that is more easy to use and provides more easy programming APIs. If you take, for example, a relational database, for example, a relational database table is something that is essentially a subset of what is contained in the commit log. It's a subset what is actually stored in the commit log. The commit log is the repository where all the mutations and events, if you will, that happens with a specific data set is going to be stored. And periodically, what relational databases do is to grab chunks of that set of mutations and to materialize into something called a table, right? If it is the case of a relational database, for example, but even if you are dealing with different database technologies, take Neo4j, which is a graph database, for example, the same principle will apply. Chunks of the mutations are going to be captured, and they're going to apply a set of data structures that is going to be optimized for graph notation. Elasticsearch, for example, a set of algorithms and data structures will be applied to those mutations to make the data available for searching purposes, and so forth, so on. So any database chooses to encapsulate the commit log somehow. But the reality is that if it's tables or indexes or whatever objects developers use to query data or store data, they are actually manipulating something that is hidden underneath the database called a commit log. So the commit log is actually where the data is stored. And the commit log is the perfect data structure for you to start writing your streams of events. And most importantly, is how you are going to share those streams of events from one application to another. That requires a fundamental change in how you are going to actually insert those events and store that data into the stream store. So the commit log is essentially a stream store. For the purpose of the remaining of this presentation, we're going to be referring to the commit log as a stream store. Now that you understood what a stream store is, let's discuss some of the lessons that you can take home to better implement your streaming-based systems. The first one is definitely trying to transform transactional data into stream of events as much as possible. In your organization and the company you work for, you're probably going to have a lot of systems producing transactional data already. And that is a data that produces an enormous value in the context of streaming-based systems, because this is the data that you can later on use to correlate with other stream of events and identify situations that can be useful for your organization as a business opportunity that you can leverage and take advantage of. There are technologies in the market that can very easily to access your transactional systems and capture the data as is and bring in as a stream of events, such as the Debezium project from Red Hat. This is a technology that uses a technique called CDC, or Change Data Capture, and allows database systems to be read and not in a table level, but in a log level. Remember, any database has a commit log underneath. So the Debezium project goes into the log level of the database and read all the mutations from the log and bring this stream of events to a stream store, which is Apache Kafka or Apache Pulsar. There are some other implementations that I know of that are being included on Debezium, but primarily is Kafka and Pulsar. And you can, from that point on, replicate to other systems and start your implementation of streaming data architectures. So definitely use projects such as Debezium to transform transactional data into stream of events very effortlessly without necessarily impact in your source databases. The second one is the usage of different programming constructs that are available in most stream store technologies. This is important because most of the time what we see out there is that developers that are afraid to go deeper into the constructs that are available to use, and they restrict themselves to scenarios that they are familiar with, such as, for example, aggregations, which is pretty common if you are coming from the database world. The problem with this approach is that you don't leverage the real power of streaming data architectures using constructs, for example, window analysis. In window analysis, you can create a temporal windows, for example, the last 2 hours or the last 5 minutes, and then you can filter only the stream of events, no matter where the source they're coming from, that are included on that window. So you can identify situations, for example, that has to do with time. The other example is to mix with aggregations. Aggregations are just like you would do in any database and queries. You can aggregate and summarize data, so you can create metrics that can be used downstream as some sort of like a signaling a business process or being just used for monitoring and observability purposes. The other programming construct that is also available, and probably the most important one, is the correlation engine that analyzes the causality or the relations between the events, and if they are somehow correlated, you can identify some patterns and causalities, such as the incidence of the occurrence of one event followed by another, and that represents a situation that you are trying to capture and leverage. So trying to mix and match all these programming constructs are going to be useful for you to leverage the power of streaming-based architectures. Same goes to trying to implement a technology, and this has more to do with the choice of stream store that you're going to use. Try to use a stream store that supports geo-replication and multi-tenancy. This is important because in the early implementations that you are going to do in your company, probably your first implementation are going to be successful because this is a proven architecture, and other projects and people within your company are going to be interested in leverage your own stream store implementation that probably has not been sized enough to accommodate multiple projects. So the ability to break down different projects into tenants is a must. So try to focus into a technology that can do this as much as it can. Same goes for geo-replication. Very often we see out there situations where you have clusters that are spread in different locations or geolocations, and because streaming-based technologies allows you to correlate data, there will be this very inherently need to link those clusters so you can start correlating data coming from different locations. This is a very natural need, but the stream store technology needs to support this. And lastly, there is always the discussion of build versus buy, right? Build versus buy is going to be basically the decision that you have to take about, am I going to build and maintain my own stream store in-house, or I'm going to outsource and buy from some vendor that produces this? There are three main criteria that you need to take care of. The first one, if you have to ask yourself, do I have a team that is capable and confident enough to maintain a infrastructure from StreamStar in-house? This has to do with a lot of things. It has to do with building a competence team, a team that is actually has the time to maintain this, and more importantly, a team that is dedicated for leveraging and continuously updating the infrastructure. If you don't have this, and if you are from the financial services industry, you're probably not going to be highly interested in keeping teams like this, because ultimately it is not your goal to produce technology. Your goal is to produce customer experiences. You're going to leverage your expertise in the financial services industry to use other than just producing technology. So this is a question that you have to ask yourself as early as possible. Same goes to data gravity. Some vendors that produce technologies for StreamStar, they're often cloud vendors, which is good in some ways and bad in others. It might be bad, for example, if your data that is coming as sources or the data that will be produced by streaming data stores and sent somewhere else does not necessarily live in the cloud. So the data gravity is going to be the decision around or how much effort I'm going to actually have to keep sending data in and sending data out from my StreamStar. So evaluate these conditions before you make a decision about your StreamStar. And lastly, you have to decide about if the vendor has a complete portfolio. StreamStar is the basic data structure that you're going to need for your streaming-based architecture implementation. But you're also going to need some other tools, such as a streaming processing framework, or what developers are going to use to express their stream processing implementation. So all of this has to be taken into consideration when you are deciding which vendor will provide a solution that is complete. Otherwise, you're going to end up with like a very siloed type of set of products that perhaps will create more friction for you every time you need to implement or change anything in your implementation. Now let's discuss some of the traps that you definitely should avoid. The first one has to do with the programming constructs that we've discussed before. Usually developers tend to reduce the usage of streaming-based architectures into aggregating data only, because somehow they are just used to this from their backgrounds using SQL databases, and then streaming-based architecture are essentially used to aggregate data and ship somewhere else. So as you may know at this point, by doing so, you are not leveraging the full power of the technology. Same goes to the continuous usage of CDC as a way for you to transform transactional data into stream of events. This is extremely powerful and important for existing systems, but for new systems, you should avoid having to rely on CDC to write stream of events. As much as possible, new applications to start writing stream of events into the StreamStar directly. And avoid this, all right, I'm used to write data into my database and then I'm going to outsource the generation of stream of events to the CDC connector. So this is something that you have to take care of. Same goes to replicating the mistake of creating silos in your organization. Now, instead of creating silos for data stores, you are creating silos for StreamStar. So a very common tendency of new teams is to use the old habit of each project will create their own set of StreamStar. And by doing so, you are not leveraging the full power of having a common backbone of communication that is going to replicate the stream of events across multiple systems. The idea of a StreamStar is to work as the central nervous systems where all the applications, the peripheral applications, are going to read and write to and from. Another point that you should pay attention is, and this has to do with the choice of technology, is pick a technology that can grow the storage of where stream of events are going to be written economically. So there are multiple implementations of stream stores out there. Try to pick one that does not necessarily requires for you to, in order to increase storage, you have to bring compute in. Most technologies has this, it looks like a lot with the Hadoop and ATFS clusters that in the big data world became like pretty famous in the past, but nowadays it's not, does not scale as we want to, and it's not very economically savvy to rely on a technology that behaves like this, because you are going to need to store large amounts of data, and you will want to, for example, leverage a technology that has a hybrid storage that can persist old data into something like an object store that is durable and cheap, and new data can be treated in hot nodes that you can actually leverage some block storage or SSD disks to actually make the data available as fast as possible. But it is important to pick a technology that can have this hybrid storage model. Also, it is important to make sure that you are not going to have this kind of a one-way direction processing all the time. As you mature your implementation, you're going to feel the need to actually, every time you need to change something that has been generated by the streaming system, you need to go back to where the data was collected or ingested or processed and do some adjustments to make sure that the new data will be generated properly. So most of the time you're developing architectures that only think forward, but never backward. So try to design your implementations in such a way that data can be continuously updated back to the stream store so that can be reused and therefore can be refined for later purposes usages. Regarding implementation technologies, there are some very interesting options out there available for you to use. Apache Kafka and Apache Pulsar, as well as the Elasticsearch, are probably going to be the main ones on the on-prem open source world. And for the cloud providers, you're going to have Kinesis from AWS, Event Hubs from Microsoft Azure, and PubSub from Google Cloud. So those are going to be the technology implementations that, if you want, we can start discussing the trade-offs between each one of them right now, because I am very glad for the opportunity to start talking with you right now alive. So let's do it.
First, thank you very much. Great presentation, great content. Connected with a different talk early today. I was with Lucas and connected your talk here, and great questions in the chat. But I want to kick off one specific kind of. I would not ask you if you should go for Kafka or Pulsar. This internet is full of opinions on that. But I'd like to have help us understanding where Elasticsearch fits in this model.
Yeah, no, sure. That's a fair question. You were right. I mean, everybody that thinks about the Elasticsearch or Elasticsearch specifically doesn't reminds in using it for streaming data architectures, and they're right. Like streaming Elasticsearch is a technology that is a data store for implementing full text searches. But what I mean by that is that I've seen some use cases where I can see clearly that people are trying to implement some analytics platform and they're using Elasticsearch, and ultimately they want to see all the data flowing in and ending up there for analytics purposes. And then they start saying, all right, I'm going to use some, I see someone asking for Apache Flink, for example, right? Mm-hmm. And then I have to use Apache Flink for performing some aggregation here before actually writing data off into Elasticsearch. And then that's the part that you don't need actually the Apache Flink for this, because you can run this aggregation on the Elasticsearch itself. So that would help you to remove some operational complexity from your infrastructure. It is not like it is right or wrong. It's more like how much like extra trouble you want to have in your infrastructure, you know. So that's the part where Elasticsearch kind of sits very well in the use case.
Yeah, makes total sense, and thank to bring light to that. So what I think we can also now get back to the chat. So people are asking for clarification. One of your questions, I think
Yes.
you reply with the classical. It depends. So can you expand now in this now live?
Sure, definitely. Let me just go back to the context where we were discussing the it depends part. I think it was when the question was about using CDC. Oh yeah, I found it here for Arjun. So he said that CDC solutions should be avoided, but they can be very useful in microservice architecture. We're doing distributed transactions, hard, blah, 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 blah. Probably it was something before that, but I remember the question. So here's the thing. Yeah, CDC, let's discuss what CDC is by definition. You are using some implementation technologies to transform raw data, stored data into a stream of events so they can become fluid again, right? Period. Then you are going to see situations where, for example, you would like to concurrently and with atomicity, right, to propagate those events to they can be used for downstream systems for analysis or for aggregation purposes, but at the same time they're being written into the let's call local data store, right? So you can achieve some sort of a consistency, right? We don't want things like, all right, I've committed this a financial transaction here in my data store, but then I forget to replicate, or it didn't went through the replication of the events for the downstream system to use. So there are techniques like the outbox pattern that you can use to ensure that consistency, and that create operational burden, right? It is all about that, right? Isn't it? Again, it is another situation that is not wrong doing this. It's more about there will be some extra steps, and don't fool yourself, there will be some extra coding from your part to implement that. So that's what I said, it depends.
Yeah, and just one step back, one thing that opened my mind when you're covering your talk is when I think about batch, I remember the batch window. That was the classical batch, but you approach it different. It's like, it's not exactly that what you're talking here. It's the dependency application in this microservice world. We see all these times the data pipeline, things that go from here to there, and this that connects to perishable data that you mentioned. And this opened my mind, how you approach streaming. That is a different perspective, how you handle the operations and all the possibilities that you bring, and remove this latency, right? That the communication between different microservices that you call silo application, but like we can connect to microservices, right?
Exactly. Yeah. Like regardless if you're implementing monolithic architectures or microservices architectures, you were doing everything right. Like there's nothing wrong with their approach. The problem is when companies start asking questions. Yeah, but I'm not being able to answer the right questions, right? Technically speaking, you are doing everything right, but the question remains. I'm not being able to let's put it like this. I'm not being able to answer certain types of questions, right? And that's where, all right, you can mix and match streaming-based architecture with your transactional architecture that you were used to it. So, yeah.
So many questions, and we have 5 more minutes only, but we'll join in the Hangouts, and I hope that we can clarify and have you there to help with that. I have one, and now I'll be very biased using my background. I've been working on rule engines, and one very good topic is CEP, like complex event process. And I'd like to understand, it's also a question that we saw in the chat. Is streaming evolution of event-based architectures? How disconnected to the world?
That's a very good question. Yes, I think, let me put it this way. I like to analyze technologies or products or whatever I'm working with as what type of problems they solve, right? So if we remember the event-based systems, or I think they used to be called local CEP, right? Like complex event processing, something like this. They were used to solve the same fundamental problems that streaming-based architectures also do. So yeah, we can think then as like they are similar. They're solving the same problem, but with some differences. I like to use the analogy, Laura. It is a Docker for virtualization, right? Fundamentally, they're solving the same problem, right? But one of them is more efficient than the other. Event-based systems in the past, and some of them, not all, but some of them, they're very memory bound, right? If you think about it, like for being able to do what they're supposed to do, which is correlating a huge set of events and producing an outcome that will be significant to the businesses and enterprise, they have to kind of allocate all those events in memory. So that creates the problem of vertically scaling, right? And that works perfectly in the past. Like if you go back like 15 years ago, we used to be, all right, 100 messages per second is our daily job, right? But now we're talking about hundreds of thousands of messages per second, and like terabytes of data is the new normal, right? So that's where streaming data architectures are becoming more popular. Again, they're solving the same problem, right? But they handle data and volume better, in my opinion. I think that's the point cut that I think separate them.
Great. And well, there's so many great questions coming up. It's like one thing that I think is very common for the financial sector to deal with legacy applications, especially mainframes. Do you have any points how to get this connection between mainframe, that's transaction applications, and the streaming world?
I don't think that has to be like a separation per se. You can definitely like live with both worlds, because here's the thing. Here's the bummer, right? Like, even though you are crazy about streaming data architecture, as I am, right? But there are applications and architectures that are transactional in nature, right? That's like a how do you say, like that's a truth in life. Just like the fact that my wife is 100% right all the time, right? That's a truth in life. You have to deal with it. And then, but you can mix and match all the time, right? You can transform just like you would do with CDC, with a local database or relational database. You can transform the data from a mainframe into event streams, right? That is possible. And there's a lot of financial institutions actually doing this already. So I don't think you have to change the way you build systems just because you want to leverage the analysis part, right? What I think you should do is, if the whole purpose of the systems is purely for an analysis, you should, start designing your systems more toward just like streaming-based architectures, because you would be able to leverage all the benefits if you're doing this.
We are getting to the end of the session, but I will ask you, Ricardo, and all the audience to jump in the Hangout so we can keep asking these questions, and the attendees will can bring out this in that place.
Let's do it. I'm all for it.
Thank you very much again, and see you in the Hangouts.